Now in this video we are going to understand about the second transformation system, which is called as a Lorentz transformation. Now before this we already studied about the Galilean transformation, which transfer the coordinate of a one frame of a reference to the another. Same thing we are going to do it over here. But one natural question comes, why are we doing again with the another transformation like a Lorentz? The main difference is that in Lorentz transformation, they consider time is absolute. That is, time is not changing. If you see the time from the stationary frame of reference and from the moving frame of reference, it is going to be same. But that was violating the second postulate of special theory of relativity. And therefore, there is a need to improve the Galilean transformation, which is improved by the Lorentz, and that's why it is called as a Lorentz transformation. So let us understand what is this transformation. In this transformation, considering time is not absolute, that means time is changing from one frame of reference to the another frame of reference. For stationary frame, the time is t, and for moving frame the time is t dash, because it is not absolute. So we will consider two frame of references, s and s dash, in which s dash is moving with a constant velocity v along the right hand side. You can see the diagram. Since time is not absolute, so the distance traveled by the light at the same point p is, from the stationary frame, it is x is equal to ct. We all know the formula, distance is equal to speed into time. So speed is constant. For the stationary frame of reference, the time is t, and for moving frame of reference, the distance is x dash. X dash is equal to c, which is the same, and here interesting thing is not t but it is t dash, because we are talking about the moving frame of reference. So we got these two equations, x is equal to ct and x dash is equal to ct dash. Now we will use the Galilean transformation. We already know that the Galilean transformation equations are x dash is equal to x minus vt, y dash is equal to y, z dash is equal to z. If we take an inverse transformation, that is x is equal to x dash plus vt, y is equal to y dash, z is equal to z. Just opposite of this Galilean transformation equation is called as the inverse Galilean transformation equation. Now if we see this both the equation, in both the equation we are taking time is absolute, which is not correct. You can see t here, t and here t is the same, that is absolute, but which is not correct. So since the time is not absolute, we have to put one constant in this first equation of the Galilean transformation by taking some constant. So let us see, x dash is equal to that constant k, x minus vt, and second equation, x is equal to k, x plus vt dash. Now here you can see that we have considered time is not absolute, that is t dash. Now to find out that this value of constant, let us multiply by these two equations. While multiplying, be careful because it is always confusing. You can do the practice of this equation 2-3 times. So here the explanations are given. When you multiply both the equations, so you will get x dash is x dash multiplied by x, that is a multiplication of left hand side, equal to multiplication of right hand side. So I just wrote this first term and then second term. I use all the steps one by one so that you will not get confused. So here it will be remain as it is, x dash x is equal to, this is k and k square, and this then multiplication of these two terms. The multiplication of these two terms is simple like a minus b, a plus b, which will be giving like this. So now after this equation, we will put the value of x is equal to ct and x dash is equal to ct dash, which we have seen below the diagram. We will substitute these two values in this equation. So we get, when you substitute on the left hand side and RHS, that is the right hand side, so we will get this thing and the common term will be cancelled. After simplifying, you will come to this equation, that is c square is equal to k square in the bracket c square minus v square. When you will simplify in order to find out the value of constant k, so you will get this factor of the constant. This value of the constant k is equal to 1 upon under root 1 minus v square by c square, which is very, very important in the Lorentz transformation. So when you use this constant in the Galilean equation, first equation, so we will get, so first equation Galilean transformation can be transferred into the Lorentz transfer equation by adding the constant term, that is x dash is equal to k x minus vt. So x dash is equal to x minus vt divided by 1 minus v square by c square. So this is the one equation we got. Now as we said, in Lorentz transformation, time is not absolute. So it is also necessary to find out the equation of time. So let us see how to find out. So now let's find the equation of time. We already know that x dash is equal to ct dash. So therefore now we will put the new value of this equation of Lorentz transformation in this equation. So when you substitute this equation x dash, which is x minus vt divided by root of 1 minus v square by c square in this equation, so we get this is equal to ct dash. Now after this we will substitute the value of x, which is equal to ct, and we can say t is equal to x by c by simplifying this. But after we will substitute in order to find out the value of t dash, that is a different value of time. We will simplify this to equation in this above equation. So we will get x is equal to x minus v in the bracket x by c bracket complete divided by root of 1 minus v square by c square is equal to ct dash. If you take now after this we will put the value of c x also, which is ct. Now here c is there and here in the denominator c is there. So if you take a c common, so it will be here, it will c square will come like this. So c will get cancelled. Why did we take c common? Because we don't want c to the right hand side. That's why we took it. And when you took and cancel, so we get equation t dash is equal to t minus vx by c square divided by under root 1 minus v square by c square. That is the equation of time in Lorentz transformation, which says that the time is not absolute, time is changing. The other two coordinates y dash and z dash will be the as it is, but only the frame which is moving along the direction which is x will be changed, and the time will be, equation of time will be changed. Thank you.